Welcome to this recording in which we are going to discuss and explore the concept of making ointments. Of course, we're talking about the compounding of ointments on a small lab scale. In this video, we're going to talk about what are ointments, ointment bases, the principles of compounding ointments, and explore some formulations that may include powders, oils, volatile ingredients, viscous ingredients, or ingredients that may stain or are malodorous. Now, you may ask, what are ointments? Ointments are semi-solid preparations for topical or external application to the skin or mucous membrane. Yes, we do have ointments that you apply inside the eyelid where they have to be sterilized as well. Ointments may or may not be medicated. Unmedicated ointments are used for their physical effects because they protect the skin, are emollients or lubricants. Ointment bases are largely categorized into four classes. These include oleaginous or hydrocarbon bases such as your petrolatum, which is white soft paraffin, or yellow soft paraffin, and we also have white USP ointment and yellow ointment USP. We also have absorption bases, for example, anhydrous lanolin. We have water removable bases, which are emulsion kind of bases, for example, hydrophilic ointment. And the fourth category is water-soluble base, which includes polyethylene glycol. But if you explore some other websites, for example, Formlabs, you will see that they have 5 categories. One with the extra one, based on exploring the site, is an emulsion base again, but this time it is hydrous lanolin. The anhydrous form is the absorption base. The one which already has water in it is the hydrous form. And as we can see over here, lanolin with the hydrous form carries 30% water, and this makes it moderate to easy in terms of spreadability. The anhydrous one, however, which is pure wool fat, is normally occlusive, non-washable, and difficult to spread. Now, this table may look a little bit blurry, but I've put the website here, Formlabs. Visit the website where you can have an appreciation for the original table. Here they have the 5 categories of ointment bases, and they give some descriptions here. Composition, water content, the affinity for water, how spreadable, washable, stable, the ability to incorporate a drug, to release the drug if it's occlusive, the typical uses and examples. In the interest of time, I will only be using the oleaginous base and then jump across to the water miscible base so you can see the extremes. So oleaginous base are anhydrous, hydrophobic, which means it does not like water, difficult to spread, difficult to wash, non-washable, right? In terms of stability, the oils. So the oils itself normally spoil easily, so it's poor in terms of stability. You can incorporate solids and oils, but not water-based ingredients. Poor drug release profile. They are occlusive, which means they cover the pores of the skin, preventing moisture from coming in and out, which is why they're very good emollients and protectants. Examples, white petrolatum and white ointment. Let's jump across to water miscible, which is your PEG, polyethylene glycol. These are hydrous, or I'm seeing here anhydrous, hydrophilic, which means it loves water. In terms of spreading over the skin, moderate to easy, it's washable, it's stable. You can incorporate solid ingredients, water-based ingredients, aqueous solutions. The release profile of the drug from the base is good. It's not occlusive, which means it does not block the pores of the skin. It's typically used as a vehicle, right? And examples is polyethylene glycol. Now go to the website so you can see the original table for better clarity. Now, ointment bases and emolliency, I had to just extract that for you because oleaginous base and semi-solids normally are described as emollient, right? They block the skin, occlusive dressing, difficult to wash off, and can stay on the skin for long periods. But what are emollients? Emollients come from the word emolliere, which means to soften. They are typically bland, fatty, oleaginous substances, hence oleaginous bases, and they they support and maintain the moisture in the skin. So it's used to treat dry skin, and it increases the tissue moisture content and thereby making the skin softer and pliable. Now, in terms of occlusive water immiscible barriers, they increase the moisture content of the skin, preventing water loss. Now, this is another word, humectants, that I had to single out as we discuss ointments, because emollients, these are used in formulation to help the water holding capacity of the skin, but they are also used in the product to prevent the loss of moisture from the product itself. So for example, toothpaste will have sorbitol, and you'll find glycerin and propylene glycol in your semi-solid preparations. Now, this is a table showing a summary of some ointment bases and their recipe or their ingredients. When you appreciate the ingredients in an ointment base, then you can also extend that into a method for making or manipulating this base to make a product. So for example, yellow ointment has yellow wax and yellow petrolatum. Why would we have yellow ointment and white ointment, you may ask? White ointment? Because ingredients which are pharmaceutical powders, very light yellow, light pink like calamine, salicylic acid is white, then you can use a white ointment or white petrolatum. This is the bleached form of the oleaginous base. But some ingredients like coal tar, ichtamol, that is black and discolored, we normally use the yellow soft paraffin or yellow ointment to help give that nice homogeneous look in color consistency. And the picture on this slide was very intentional. You can see that dark color coming out. This is what your yellow ointment would possibly look like. Now, the absorption base, on the other hand, would have cholesterol, stearyl alcohol, and white wax. Now, these are all things which help to emulsify and stiffen the ointment base, right? And so if you were to use this to make a product, your method would be very different if you were using, say, white petrolatum alone to make a product. Now, over here, we have water removable base. Water removable is easily washed from the skin because it has, look at this, sodium lauryl sulfate. It's a surfactant that's used in a lot of detergent. And so for this one, you have two preservatives, methyl and propyl paraben. You do have your humectant here, propylene glycol. Stearyl alcohol helps to stiffen and add body to your ointment. You have the white petrolatum, which is your emollient. And you have purified water, which is a part of the aqueous phase in making this preparation. So the water will be used to dissolve things like your parabens and your sodium lauryl sulfate, because those have a great affinity for water. Now, a beautiful emulsion will come together when you merge the oil and water phase along with the emulsifying agent. Now, water-soluble base includes polyethylene glycol, and you have different categories of polyethylene glycol. I think 400 is the liquid, and the higher number is a semi-solid. And if you were varying your ointment consistency, you can change the proportion of the 3350 peg to change the consistency. Now, how do we make ointments? Ointments can be made using different techniques. And so this slide, I've summarized it for you. So let's look at it. Yellow ointment. You melt the yellow wax on the water bath, of course in a porcelain dish, because none of these ingredients will stain. If the ingredients had stain, then you'd stick to like things like a glass beaker or really thick glass that can withstand heat on a hot plate or a water bath. But for this, we can use our porcelain dish, or what we call our crucible. You melt the wax, of course, according to the melting point, and you add the ingredient, which is the petrolatum, with a lower melting point last. You Remove it from the heat source, stir it until the ointment cools and congeals nicely. Now, if you are using a glass packaging or even a plastic, you have to be careful of the heat. Some persons can choose to pour the ointment while it's congealing in a nice thickened form, and so it finished sets inside the jar. Just do not pour the hot melt, we call it, as you remove it from the heat. Just don't pour it into the jar. Allow the temperature to drop a little bit before you pour it into the jar. Now, let's look at this one. Cholesterol, sterile alcohol, white wax, and white petrolatum. You melt the sterile alcohol and the white wax on the steam bath. Then you add the cholesterol and stir it until it dissolves in the oil phase because it's compatible with the oil phase. Then now you add the white petrolatum last and you remove it from the heat source.